Hello, scholars. This is me, Joseph Ejike Oji. Today, I'm going to keep you company by teaching you a concept that we do in statistics. That concept is part of statistical test of hypothesis. I know I have taught a lot of topics on testing hypothesis, but this one is a new topic on that. It is called the z-test for the mean, the z-test for the proportion. Now, let me start by sharing my screen and making sure you are seeing this. Excuse me. Okay, let me make sure you are seeing all this. Okay, I think you're seeing it. Okay, good. Z-test for the population proportion. So, when we say population proportion, we are referring to the part of a whole, like 50%. Basically, it's a percentage. They say 50% of the population of students enrolled at Morgan State University in 2025, something like that. So that percentage is 50% is a proportion. And excuse me, that's what we're looking at here. We can run a statistical test for the population proportion. And that's what we're doing. I'm going to introduce it tonight. We are going to do more examples of that. Tonight we'll be focused on one case. However, before I move further, I want to introduce you to what we actually do when we run a z-test for a population proportion. Now, in the z-test for proportion, what we do is to test a sample to test if a sample proportion is significantly different from a known or a claimed population parameter, which in this case is a proportion. We try to compare the sample result to the population using a z-score formula, which we normally call the test statistics. So in this case, if the z-score is far from zero, then we infer that the difference is likely not due to chance. What do we do with this? Well, it helps us to decide if what we see in our sample is true. I mean, if we can generalize it for the whole population. Look at this example here. Say a school claims that 60% of its students pass maths. We survey 100 students and find only 50% passed. Now we can use this test for the proportion to check if this drop is meaningful. Now somebody can say, oh, it's already sure that 50% is less than 60%. So we already know that the claim is not correct. So why are we running the test? Well, I want to remind you that this is from a sample of 100 students. We don't know how that sample was selected. We don't know whether it is properly randomized. And this is in a population of students in that school. We don't even know the population, how far this sample of 100 go towards actually representing or reflecting the different segments of the population of students in that school. What I'm trying to say here that is it a representative sample of the population of the student in that school? We don't know. So it's a sample, so we have to test to see if this drop is true for the entire population. That's why we still have to run the test, especially given that we don't have the student population standard deviation. I mean, the standard deviation for the entire student population in that school. How about the second example? You say a company say that 80% of customers are satisfied. A survey shows only 70% are. Now, we can run a z-test to help find out if this is just a sampling error or a rate drop in satisfaction. Now, I think I've given you some information that you need to know. Background information, I call it. So I call it background information. Now, let us proceed to the steps, general steps for running a z-test for a proportion. So the first one is, or the first step is, you state the hypothesis and identify your claim. In my previous videos, I have explained how to state hypothesis. So you can go and watch some of them if you forgot how to do it. Then next thing is to find the critical value. That is step 2. Step 3 is to compute the test statistic or the test value using the given formula. And then step 4 is to make a decision to reject or not to reject the null hypothesis. We normally represent the null hypothesis with HO and alternative H1. Then last step was summarize the results or make a conclusion. And the general formula we use, you can see from here, from the screen, the general formula we use is Z equals P hat minus P over square root of P hat times Q hat over N, where P hat is the sample proportion given by X over N, and N is the sample size, P is the population proportion. Now there's a part we also use, the Q part. Q is simply 1 minus the P. That is 1 minus the sample proportion. So tonight, we're going to work only on one case. The case that involves a two-tailed test. If you don't remember what the two-tailed test is, I will say I made a video on that already, so you can check that. So let's look at this first one case that has a two-tailed test. Make it bigger so you can see it better. Okay. It says here that an educator, okay, let me see if I can see this. An educator estimate that the dropout rate for seniors at high schools in Enugu, Nigeria is 15%. This is among high school students. So last year, 38 seniors. When they say seniors, they mean in Nigeria, they call it the SS, senior secondary students. Like we have SS1, SS2, SS3. Well, that's what they call them in Nigeria. Anyway, last year, 38 seniors from a random sample of 200 seniors at a high school in Enugu withdrew. At alpha 0.05, is there enough evidence to reject the educator's claim? Let's solve this. First thing is to state hypothesis. Identify our claim HO and H1. Yeah? HO and H1. He said that an educator claimed that the dropout rate for seniors at high school is, see this keyword there is. Is means equal. So we have P equal to 15%, which is 0.05, 15%. And that is the claim right there. So in this case, the claim is in the null hypothesis. The alternative hypothesis always says the opposite of the null hypothesis, which indicates that P is not equal to, let me see, to get not equal to, we gotta insert it. Symbol not equal to 15%. And our alpha is giving us alpha 0.05, which is 95% confidence, okay? Alpha is 0.05. So next thing is to find our critical value. to find the critical value. This is a two-tailed test. There are so many ways you can get the critical value. But normally, if it's a two-tailed test, I like to use a shortcut method. So I'm going to use, since it's two sides, I'm going to use Z alpha over 2. This is two sides. Z alpha over 2 equals, this is, alpha is 5%. That means their chance of being right is 95%. So I'm going to use 95. Normally, the formula is P over 200. This is my shortcut method I used to get it. The other way is you can use the conventional method, but this will give you the same thing. Why 200? People ask me that. Why 200? Well, 200 is, remember, a percent is 100%. 100. So since this is two sides, 100 hundreds, that's where the 200s come from, according to this concept I'm using. According to this, so 95, because it says alpha is 5%. So, I mean, the probability of committing a type 1 error is 5%. So not committing it is 95%. So 95 by 200. That gives me, let me put a calculator so you can see. I have my calculator somewhere. Let me open it so you can see it. Right here, my calculator. I'm going to share it. 95 divided by 200. 0.475. 0.475. 0.475. Because the table of normal distribution has 4 figures. That's why I make it 0.4750. Now, from that table, we find a critical value. I'm going to call it critical value. Critical value, which is Z alpha over 2 is. Let's go and look at it on the table. So you open your statistical table, look at the table of normal distribution, or the Z table. I'm sure you can see it on the screen. Now, in that table, you look for the value 0.4750. So I'm going to write it down. 0.4750. 0.4750. Look for it inside the table to get the Z value that corresponds to that. So look at 0.4750. Let me make it a little bit bigger. 0.4750. I'm sure you're seeing this. Okay, I've seen it. 4750. You can see right here. You can see right there. And you follow it to the left, all the way to the left. 1.9. Then you follow it up. 6. 1.96. So the critical value is 1.96. Okay, 1.96. Now, so we have stated the hypothesis and identified our claim. We have got our critical value. Now we're going to go to stage 3, which is compute the test statistic. So let's do it. For that, we need this formula here. I'm going to copy it from here. So the formula, I'm going to paste it there. Right here. Okay. That's the formula we'll be using. So let's get our values. P is 15%. P equals P equals 15%, which is 0.15. I'm going to make this in bigger. Yeah, I'm going to make it bigger, 18. And the Q will be 1 minus P. which is 1 minus 0.15. So from our calculator, you have that 1 minus 0.15, 0.85. 0.85. 0.85. Okay. Now, our n. So you said that our n, you said a sample of last year 38 seniors from a random sample of 200 seniors. Okay. 200 Ohio seniors. Okay. I think it is a 38 seniors from a population. So you gotta be, you got to be, I think I typed this question wrong. Okay. Yeah. From a student, from a population out of 200 seniors selected at 8. Okay. 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 That's gonna be, yeah. The question is worded correctly. That 8 seniors out of 200 seniors withdraw. So our x is 38. Our x equals 38. And our n is equals 200. So that our p hat, I cannot put the p hat here because it won't allow me to put it. So I'm gonna put it in the other workbook and then copy it and paste it here. So that our p hat, so I'm gonna insert it. P hat make sure I'm seeing this properly. Okay, p hat, let me see. P hat. Yeah, this is, I have the correct right here. P hat. Small p hat. P hat equals, let's make it big. Probably 18, because 18 will be better. Equals x over n. X over n. Okay, which is, you can see from the other workbook that our x is 38 because you say here 38 seniors from a random sample of 200 seniors at the high school in Enugu. So our s is 38, our n is 200. So you got 38 over 200. And that gives us 38 divided by 200 from a calculator. 38 divided by 200. 0.19. 0.19. 0.19. So now I'm going to copy this and paste it in that slide. I mean, in the other workbook. Okay. To this one. Good. So we have everything we need. We have our P, we have our Q, we have our P hat, we have our N. So we can now apply this to this equation, to this formula to run the test. Okay. So I'm gonna copy this and paste it inside the other workbook so that, because this one will not allow us to use the formula. So let me paste it here. So let's run it. Okay. Equal. Remember, before we do that, I want to remind you again that P hat is 0.15. P is 0.15. Q is 0.85. N is 200, P hat is 0.19. So we plug these numbers into this formula. So let's go and plug them in and then get our answer. Okay? Equals, okay, our P hat is 0.19 minus Q, P, which is 0.15, divided by the square root of, okay, P times Q, P times, oh, not that. P, we know P already. P is 0.15, 0.15 times Q, which is 0.85, for N, which is 200. So let's get this from the calculator, okay? So we go to the calculator, we have, okay, we have 0.19 minus 0.15 divided by the square root of 0.15. Oh, okay, excuse me. Times 0.85 over 200. 1.58. 1.58 rounded. So the answer is 1.58 rounded. So I'm going to put it right there. 1.58. That's the result. So we have run the test, and the result is 0.15. So I'm going to copy this and paste it in our other workbook, the main workbook. Results here. So we have run the test. This is the result. Now let us remember, after once you get the result, the answer, next stage is to make a decision to reject or not to reject null hypothesis. Okay, let's make that decision. Okay. Decision. Okay. The decision is made based on, our decision is always based on critical value or p-value. With this one, we're using critical value. The critical value, we'll have it at the beginning as, excuse me, we'll have it as 1.96. The calculated critical value is Z alpha over 2. That's Z alpha over 2. Okay? The calculated value, okay, that's our answer. Calculated value is Z equals 1.58. Now, those of you who have watched my previous video on test of hypothesis know that critical value criteria means that if the answer is bigger than critical value, you reject null hypothesis. But if the answer is equal to, if the answer is equal to or bigger than the critical value, you reject null hypothesis. But if the answer is less than the critical value, you do not reject. So here, our answer, which is 1.5, is less than the critical value. So do not reject. Do not reject the null hypothesis. Now let's conclude. Conclusion. So you see, we do not reject this is not hypothesis. HO, the proportion is equals to 15%. Yes, and that is where the claim is. So we didn't reject it. That means the claim is correct. So we have sufficient evidence to support the educator's claim that the dropout rate for senior at high school in Enugu is 15%. So we did not reject no hypothesis, which means that the claim is correct. So we say that we have sufficient evidence to support the claim, the educator's claim. Okay, that the dropout rate for seniors at high school in Enugu, Nigeria is 15%. That's it. That's how we do. That's what we do when we test hypothesis for proportion. Remember, this one is for proportion, not for the mean. The one we did is for the mean. I mean, the one we did before in my other videos is for the mean. This one is specifically for population proportion. And today we focus on case 1 for the two-terror test. In my next video on this, we focus on case 2, which should be left terror test or right terror test. So thank you for watching, and I'll see you in my next video. Bye-bye.